just discuss about what is a sample space, and then we'll go in this order. Okay, so the next term that you should know is what is a sample space. Okay, instead of writing this, I'll just write sample space. So what is a sample space? So a sample space is nothing but, for example, if I roll a die, right? If I roll a die or toss a die, so what are the set of possible outcomes? What all we can get? Either you can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So these are the only possible outcomes that I can have, right? So this is my sample space. I can get only anything between from this set of numbers only. I cannot get a 10 when I roll a die. This is outside my sample space. Okay, I cannot get a -1 when I roll a die. This is outside my sample space. So my sample space is only this. So this is my sample space. So if I want to define it formally for you, it contains all possible outcomes of an experiment. Outcomes of an experiment. So this is what is a sample space. So I can give you more examples. For example, if you have if you want to you have the number line and you want to choose any number between 1 and 2. So my sample space is this whole number line segment, the whole range. So what will be the number of what will be the range of this? How many numbers are possible between 1 and 2? How many real numbers are possible between 1 and 2? That will be infinite. This will be infinite, because you can have anything between, say for example, if I have 1.2, I can have 1.21, I can have 1.211, I can have 1.2111, and so on. So these numbers are infinite. Okay, so this is, I hope you understand what is sample space. Okay, these are all the possible outcomes when you say that. Okay, when you do an experiment. So my experiment is, like for example, in this case is, my experiment is to find any number between 1 and 2, and there can be infinite such numbers. Okay, so this sample space. Okay, so there is something more advanced stuff that I'll just mention here, and the lecture notes, what will have, the notes will have the details of that. So you should know that this sample space should follow something called, it should follow the rules of sigma algebra. It's just good to know stuff and some advanced stuff. Okay, so there are some rules that this sample space should follow, but I'll not dive deep into this. I'll write it in the notes and share it with you. Okay, so don't worry, but you should just know about this, that this sample space should follow the rules of sigma algebra. Just good to know stuff. Okay, so this is about sample space. Now let's move to the next topic. The next topic would be what is discrete and what is continuous. What is discrete and continuous? So what is discrete? For example, discrete is anything that is countable. For example, when I do toss a coin, there are only two possible outcomes, right? Head or tail. So this is discrete. If I roll a die, I can have only 1, 2, 3, 4, 5, 6. These are the only possible outcomes. So this is discrete. Okay, and then we have something called, okay, so for example, if I am sitting on a traffic light, okay, I'm sitting on a traffic light and measuring the number of cars, sitting on a traffic light and measuring the number of cars that are passing through that traffic light or crossing that traffic light in 1 hour. This is also finite and fixed number of events. So this event is also discrete because that's countable. Okay, so this is discrete. So let me rub this off for avoiding confusion. So this is only about discrete. These are discrete events. I hope that is clear. The next thing is continuous. So continuous is anything that is like a graph, anything if you have like this, right? So this is a continuous graph. If you see, there is a continuity. So this is continuous. There can be infinitely many points between any, if you take any 2 points, right, there can be infinitely many points. This is continuous. Similarly, on a line segment, the previous example that I mentioned, if you have to choose any number between 1 and 2, okay, so this, there can be, in this range, there can be infinitely many numbers. As I mentioned earlier, there can be 1.2, 1.211, 1.2111, etc., etc. So there can be infinitely many numbers. But just understand one more thing here. Say for example, if you fix the places of decimal to which we are counting. Say for example, if I say that if I will count only till 2 places of decimal, okay, then this becomes countable because we know how many numbers there are. This is countable. So then this becomes discrete. If you fix the number of places after decimal, okay, in the range that I want the numbers to be. So this is my continuous. Okay, so it can take any value within a given range. So this is your discrete, this is continuous. Okay, also for example, if I give you one more example, say I have a rectangle, and if I want to put any point in this, there can be infinitely many such points that can be put in this region, right? So this is also a continuous variable, or a infinitely many possible points can be put in this. Okay, so to summarize this, so you have a sample space. So I have a sample space. So this can be divided into 2 parts. So it can be either finite or infinite. Okay, so if it's finite, then it's discrete. We know roll a die, you can get a finite number of events, finite number of possibilities. So that's discrete, no problem. But if it's infinite, then either it can be countable or uncountable. If it's countable, then we say that it's discrete, and this is the only case where it's continuous, when the possibilities are infinite. This is discrete, this is discrete. Anything that is countable, even if it's infinite, okay, say for example all the numbers on the number line, even if it's countable, we have like all the numbers on the number line, 1 2 3 4 5 6, like this till infinity. So these are countable. So this is also discrete. Okay, discrete. Okay, so we have understood what is sample space, we have understood what is discrete and what is continuous.